If we wanted a function that can return a Boolean value, we might say isValid equal to check and generate that. Now we're not too bothered about the actual implementation of this function, we just want to use it as an example. So let's just return true and annotate this function with a return type of bool. So let's just run this code to make sure it works. And we have a warning saying that isValid is not being used, so we can just debug that to get rid of the warning. Okay, all looks good so far. But now let's just check with Clippy to make sure we're doing things in an idiomatic Rust way. And when we run Clippy, we can see that we have a bit of a warning here. Unneeded return statement. It's offering us some help, remove return true. So let's go and do that. I guess we can't remove that part because that is the return type, so we'll just delete that instead. Doesn't look right. Let's see what it says when we run it. Now it's a compiler error. It's saying that check implicitly returns unit. That's what the open and close parentheses mean in Rust. As its body has no tail or return expression. Okay. And the next bit of help is consider removing the semicolon. So if we do that, it works as expected. That was just Clippy, so let's actually run it to make sure the debug still works and it's valid is equal to true. So what we say is that it's not idiomatic Rust to have the return keyword if the thing you're returning is the last or the tail or the trailing expression of a function body. Now the part I've got highlighted there is actually known as a block expression. And block expressions have a default return type of unit. So if I remove any code from this function, I'm going to see this error here. And it says it's a mismatched type. It expected a bool but found a unit. So if I get rid of this return type, this is a perfectly valid function, but it does have a type of unit. So we can say that when we provide a type signature like this, we're essentially saying to the Rust compiler that the following block expression will evaluate one way or another to a Boolean. And by having just the keyword true at the end, this is the final expression of this block expression, so that becomes the return type. Now, you couldn't have something like a let binding in here. If we said num equals 10, that's not going to work as a return type because this is known as a statement. More specifically, this is a let statement and it has no return value. So you can't even do this. The only way that this is a valid line of code in Rust is if we put a semicolon there. And this is what we mean when we say the tail expression. Because we can have any number of statements, but whatever is the last thing in the function that is a valid expression will get returned. So whilst we get some errors about unused variables, this is still completely fine. Now this works because these outer curly braces are evaluated just like any other block expression in Rust. And what I mean by that is, inside of this function, we could technically have another block, and another block, and another block, and as long as I return true here, as crazy as it seems, like this will work absolutely fine. It kind of makes more sense if you put it onto the same indentation level like this. So what we would say here is, this is a block expression, and it's going to return its final or its tail expression. That happens to be this block expression, which is going to return its final expression. Same again, same again. And finally, because this one is a valid candidate for a return type of its outer expression, that goes all the way up the chain and we end up with Boolean here. We can really prove this by, if we put a semicolon there, we've now just broken the return type. Because this function now no longer returns this expression, because this block here now has the type unit, which means this has the type unit, which means this has the type unit, this has the type unit, and to make this work we would have to go in here and explicitly say that we return unit here. So this is what returning values is all about in Rust. It's why you see things such as, if we had like num equals 10, and we wanted to return true or false based on whether that number was over 5, for example, then we could do this. We could say if num greater than 5, true, else false. This may seem strange to you if you've not used a language that returns final expressions like this, but if you break this down, this is just the same as when we had those nested blocks. In Rust, this is an expression. We can prove it by saying is valid and assigning the result of the if expression to this variable, but then we would have to close this off here with the semicolon, because remember, let bindings are never valid as a return type. So we have to terminate that there, and then to return is valid, we can just put is valid. So now this becomes an expression which is the final expression of this block, and it becomes the return type of this function. But again, the idiomatic Rust way to do this would be to remove the semicolon there, remove the let binding, and just have the final expression be the return type. Now, another example is if you had a match expression here. This is one that you'll see very, very commonly in Rust code bases. Let's just say we had a true, and let's just say if it was 6 to 10 inclusively, return false, and we'll have a catch-all for any rogue values that we don't know about. We'll say false. Although we could write return here to make these do an early return, there's no need in Rust, because as you can see here, it's telling us the return can be lifted out of match. There's just no need to work in this way. So let's get rid of the return statements. Now what we're doing is we're saying that this is the final expression. It's going to evaluate whatever the match expression evaluates to, and that becomes the return type here. If we look at some standard library functions, we can get some examples of this. So if we look at this one, this is none on option. Let's break it down. You can see that the return type is a bool, but the function body just contains a single expression, which is the negated version of self.isSum. So there's no need in the standard library to write return here, because the final expression is the return type. Let's find another example. Here you can see we've got a match expression, and this actually is where it's broken onto multiple lines is because we have this where clause. But if you ignore that for a moment, you can see that this is the same as our block expression on the outside here. And it contains one inner expression, which is a match expression. That's the final one from this block, so it becomes the return type. But the return type is, in this case, the return type of this match expression. So returning values in Rust is all about understanding the difference between statements, understanding what semicolons do. For example, placing a semicolon at the end of this match expression converts it into an expression statement, which is no longer going to contribute to the return type here. We would have to say is valid, assign it to a variable, and then provide that as the final expression.